We're now going to move to the analytical section, because writing equations and filling out charts and graphs really doesn't do us any good unless we can interpret what this means. So our first question here, what is the slope of the function? That's pretty easy to get from our equation. We could have also got it from our graph, or if we wanted to use the slope formula from our table using 2 points. From here, 0.06 million is how much it's increasing each year, so we'll write that the slope is the new number of girls playing sports each year, and I kind of jumped to what it meant. The slope is the new number of girls playing sports each year, which is 0.06 million. Our next question, what is the y-intercept of the function? We can again get that from the graph where it crosses the y-intercept or y-axis, or we can get it from the graph. Right here we see that the y-intercept is 2.6 million. That's our starting point. And what does that mean? That means that's how many girls had already played sports prior to 1997. So the y-intercept is 2.6 million. This is how many had played prior to 1997, and including, because we're talking about years after 1997. Finally, predict how many girls will be playing high school sports in the year 2017. Explain how you arrived at your answer. Well, if our graph went that far, we could look at that, but I didn't make mine with enough detail, so I'm going to use my equation. So first I need to figure out the years past 1997 that 2017 is. So find the difference between 2017 and 1997. Subtraction problem. 2017 minus 1997. 0. Some of you might have been able to do it in your head. 2. So 20 years. We can then put this in our equation. Y equals 0.06 times 20 plus 2.6. As we do the math out, 0.06 times 20 is 1.2 plus 2.6. 1.2 plus 2.6 is 3.8. And remember, we're talking about million girls have played high school sports by 2017. So there's an overall idea on how to complete your graphic organizer. Good luck.